Hello, everyone. In this session, we're going to look at the final exam review problems for ecore college algebra. Okay, for question 1, we're going to factor 25x squared minus 81y squared. Now, if you look at 25 and 81, they're both perfect squares. And so if you're taking a difference of two perfect squares, and we know square root of 25, x squared is 5x, and then square root of 81, y squared is 9y. We can write this as 5x, and then 5x plus and minus 9y, 9y. So the fully factored expression is 5x plus y, 5x minus 9y. The formula I'm referring to is whenever you have a squared minus b squared, it factors as a plus b and a minus b. Okay, question 2, we need to factor this trinomial x squared minus 12x plus 36. Now, if we have a trinomial, I use the big X method, where you take the c term, the last number, you find a product of 36, that'll give you the sum of the b term, which is middle negative 12. We have negative 6, because negative 6 times negative 6 is 36. The sum, negative 6 plus negative 6 is negative 12. So we factor it as x minus 6 and x minus 6. And then since the factors are repeated, we can write it as x minus 6 squared. You can again check by doing the FOIL process and multiply it all out. Number 3, we have solve the following equation for x, 6 parentheses x minus 3 plus 5 equals negative 5 plus x minus 4. So we can distribute the 6 and get 6x minus 18 plus 5 equals negative 5. There's nothing to distribute in front of that x minus 4, so we can just take the parentheses off. Let's combine like terms. We have negative 18 plus 5, and that's negative 6x minus 13. And we can combine negative 5 and negative 4. And that gives us x minus 9. Now we can subtract x to gather all the x terms on the left. And at the same time, we can add 13 so that the constant term or the numbers are on the right. And we have 6x minus 5x, which is 6x minus x, which is 5x, negative 9 plus 13, which is 4. And finally, we can divide both sides by 5. And that'll give us x is equal to 4 over 5. Number 4, we have, we're going to solve the following quadratic by factoring a squared minus 3a minus 4. So using the big X method, what multiplies to negative 4, but adds to negative 3. And that's going to be, let's see, 4, negative 1, positive. So we have factors as a minus 4 and a plus 1. 0. So after you factored it, right, we have to set each factor equal to 0. Then we're going to add 4 to both sides and get a is equal to 4. And we subtract 1 on both sides here, and we get a is equal to negative 1. So the solution is negative 1 and 4. Just separate it with the comma. Okay, number 5, which of the following is an integer? So we have to go back to what are integers. Integers are all the whole numbers and their negatives. Okay, so 2 is an integer. We have negative 6 is an integer. Negative 19 is an integer. 3 is an integer. 20 over 3 and 10 over 3 are not integers. So I guess I'll when you type it out, we have 2, -6, -19, and 3. Okay, number 6, find the slope of the line through the points -1, -7, and 0, 9. Okay, so we have to remember the slope formula, which is y2 minus y1 divided by x2 minus x1. So let's label our points x1, y1, x2, y2. So we have -9 minus -7 divided by 0 minus -1. -9 minus -7 becomes -9 plus 7. And denominator we have 0 plus 1 because a negative makes it turn positive. So in the numerator, we have -2, 0 plus 1 is 1. That simplifies to -2. Okay, number 7 is find the equation of the line through -7, 2, which is parallel to the line y equals -8x plus 7. So if it's parallel, if the line that we're trying to find is parallel to this line, means it has the same slope. So I know the slope that we're going to use is -8, and -7 and 2 is our xy value, and that'll help us solve for b, the line intercept. So into this equation, y equals mx plus b, going to substitute 2 for y, -8 for m. Don't need parentheses there. And x is -7, and we're going to solve for b. So we have 2 equals -8 times -7 is positive 56 plus b. We subtract 56 on both sides to isolate b. We have b is equal to -54. Now using that, I have to rewrite the equation with our m and our b. So the equation of the line is y equals -8x minus 54. So remember not to just stop here. You have to put it all back together after you find the y-intercept. Reuse that to write the equation of your line. Okay, let's look at the next one. Question 8, find the local maximum and minimum of the graph shown below. And so we have the maximum or local maximum point right here. That's going to be at 4, 3. And so this is our local max. And our local min, the lowest here, is like where you see a dip. This is our local min, is at 0, -4. So again, I'll just write local max is 4, 3. And our local min is at 0, -4. Okay, number 9, determine the intervals for which the function shown below is increasing. So you always want to read the graph from left to right. And so as you move I guess if you think about moving your finger along the graph from left to right, think about when you're, when you're tracing it, when it goes down. So as you trace, right, it goes down from this point, and actually I should highlight it. If I'm tracing, so it starts going down from this point to that point, and it goes up again, and then it starts going down again or decreases in that section. And with decreasing intervals, you always want to report the x value. So it decreases from, you can see here, which is -3. And then it goes up until right there. And if you read the x value, it's 1. So it decreases from -3 to -1. And then it skips, and then it goes up again. And from 4 on, which is 4 to the right, which is 4 to infinity, it decreases. So it decreases for all the x values from -3 to -1. We use that union symbol, 4 to infinity. Okay, so now let's look at number 10. Okay, number 10, we need to find the average rate of change of the given function on the interval 5 to 6, where h of x is 4x squared plus 4x minus 8. So the average rate of change is kind of like your slope function, where you're taking y2 minus y1 divided by x2 minus x1. And usually we write it as, if we know that 5 is your x1 value and your second x value is 6, okay, we can write this as h of 6 minus h of 5 all over 6 minus 5. So we need to calculate what h of 6 first. That's our y2 value, or second y value. And I'll do this on the side. If we have h of 6, we're going to plug it into the function for parentheses 6 squared plus 4 parentheses 6 minus 8. And I'm just going to calculate that using my calculator, and we get 160. We have h of 5 is 4 parentheses 5 squared plus 4 times 5 minus 8. If I calculate that, that's going to give us 112. So I'll plug that in. So h of 6 is 160 minus 112. 6 minus 5 is 1. And 160 minus 112 is 48 over 1, which just simplifies to 48. And so kind of like the slope function, except this time you're not given the y value. You have to find the y value itself that corresponds to your given x values. Okay, question 11 is the graph of y equals 3, f of x plus 2 minus 4 is the graph of y equals f of x, and we need to do the transformations on it. So looking at 3, I know that's going to be a vertical stretch by a factor of 3. So this says vertically compressed, so let's just eliminate those. And then the plus 2 is going to be a shift to the left 2 units. And then a down 4 units because of the minus. And so this is going to be let's see, it's the last one. Vertical stretch by a factor of 3, shifts left 2 units because of the x plus 2, and minus 4 is down 4 units. Okay, number 12, which of the following graphs shows a graph of 1 to 1? So graphs of functions that are 1 to 1 has to pass the horizontal line test. So if I draw a horizontal line through this one, if it hits it more than once, it fails a horizontal line test. I'm going to X this one. This one is good because if you draw a horizontal line, it only goes through it once. This graph is also good. And this graph down here, because it goes through it more than once, it fails. So the only two are this graph as well as this graph. So it must pass the horizontal line test. Okay, number 13. Which of the following function, or given the following functions, find and simplify f times g of x? So we need to multiply these two functions together and just simplify. So if we multiply f times g, we have f, which is negative 2x plus 3. We're going to multiply x plus 3. And so we're going to multiply negative 2x times x, which gives us negative 2x squared. Negative 2x times positive 3 is negative 6x. Multiply positive 3 and x, we have plus 3x. And 3 times 3 is positive 9. And then negative 6x plus 3x. If we combine those, it becomes negative 3x. And let's bring down, negative 2x squared. And then we have minus 3x plus 9. Okay, number 14, given the following functions, find and simplify f plus g of 1. You could do this by first adding f and g together. And so if we add f plus g, we get f of x plus g of x. We'll first add those. We add negative 2x squared minus 2x plus x minus 2. We can combine negative 2x plus x, gives us negative 2x squared minus x minus 2. And we just need to plug in 1 in here now. And because this is f of g of x, and if we just plug in 1 into this function, we get negative 2, 1 squared minus 1 minus 2. And if we calculate that, that'll give us negative 5. Okay, number 15, we're given the function f of x equals 3 square root of x minus 3 minus 6. And we need to find the inverse function defined on the domain where x is greater than or equal to negative 6. So first, we're going to rewrite this function as y equals 3 square root of x minus 3 minus 6. So we rewrite f of x as y. It's just easier to work with y. And then the second step, you're going to, actually, I'll just label it here too. Second step is you're going to switch the x and the y's. I'll just write it like this. All the x's and the y switch. So we have x equals 3 square root of y minus 3 minus 6. And then this third step is you're going to solve for y. In this case, we can add 6 to both sides. And we get x plus 6 equals 3 square root of y minus 3. And then we're going to divide both sides by 3 to cancel this 3 in front of the square root. And we get x plus 6 over 3 equals square root of y minus 3. And to take the square root off, we can take the square of both sides. That takes care of the square root. I'm going to go over here since I'm running out of space. So we have x plus 6 over 3 squared equals y minus 3. And finally, we could add 3 to both sides. Actually, I'm going to just divide this over here, 2. And write this is x over 3 plus 6 divided by 3 is 2 squared. And then if we add 3 to both sides here, that'll cancel the 3. And so we have plus 3 equals y. And that's actually our inverse function. Our inverse function of f is x over 3 plus 2 squared plus 3. Okay, number 16, determine the vertex of the parabola of whose equation is given below. So the vertex of a parabola is its minimum point in this case. If it's an upside down parabola that faces downwards, that would be a maximum. But in this case, the vertex is located right here. And it's for this one, it's -1, 3. Okay, number 17, we're going to locate the x-intercepts of this parabola. The x-intercepts is where it crosses, where the graph crosses the x-axis. So here's one x-intercept at -2 and 0. Here's another x-intercept, 2, 0. So our x-intercepts are -2, 0, and 2, 0. Okay, so make sure you type it in like this with separating the 2 points with the comma. Okay, number 18, we have, we're now again determining the vertex of this parabola, negative parentheses x minus 3 squared minus 3. And how we find the parabola is you take the x value is the opposite of what's in the parentheses. So if it's -3, the x value is going to be +3. And the y value is going to just be taken as is. So it's -3. So with x values, you look to see the opposite of what's inside that parentheses. So if it's positive, it would be negative, but in this case, it's negative. So the x value is positive. The y value just take what's at the end here. And so the vertex is 3 comma -3. 19, we have the polynomial f of x given below has 2 as a 0. We're going to find the zeros of all of the f of the function. So we can actually use synthetic division because we're given that 2 is a 0. And first I'm going to rewrite this as x to the third plus 0x squared because the x squared term is missing and you need to have a placeholder for that, plus 6x minus 2. I'm going to use 2 as the for my synthetic division, and then bring down the coefficients 1, 0, 6, and -20. And then we're going to bring down the first number 1, and you multiply everything by 2. So 1 times 2 is 2, and we add that column, we get 2. You multiply again by 2, and 2 times 2, and we're multiplying by 2 because that's the given value, that's a 0. So 2 times 2 is 4. We add that, we get 10, and 10 times 2 is 20, and we get a 0. So that's a remainder, and that's not a surprise because if it's a 0, the remainder should be, or if it's an x-intercept, that 2 is given as the remainder is 0. So if I use this and bring that down and rewrite that as 1x squared plus 2x plus 10, set it equal to 0. I don't think that's factorable because you don't have a product of 10 that'll give you a sum of 2. So now we have to resort to using the quadratic formula, which is x equals -b plus or minus the square root of b squared minus 4ac, all divided by 2a. And in this case, a is 1, b is 2, and c is 10. So we have -2 plus or minus the square root of 2 squared minus 4 times 1 times 10, all divided by 2 times 1. So we get -2 plus or minus. We have 4 minus 40 all over 2. We have -2 plus or minus the square root of -36 over 2. And square root of -36 is 6i. So -2 plus or minus 6i over 2. You divide the 2 by 2 and the 6 by 2. So you have -1 plus or minus 3i. So our solutions, the other zeros are -1 plus 3i, so this one here, and -1 minus 3i. Okay, number 20, we're going to use a compound interest formula for this. 25,000 borrowed with 8% interest rate compounded annually. What's the total amount of money needed to pay it back in 10 years? So the formula, if you recall, is A equals P1 plus R divided by N raised to the NT power. P is your original amount that you borrow. So here P in this case is $25,000. Your interest rate is R. It's 8%, but we need to change it to a decimal by either dividing by 100 or moving the decimal over twice, 2 places to the left, so it's 0.08. N is a number of compoundings. This says annually, so that's going to be once a year. And then T is 10 years. So we plug it into this formula. We have 25,000, 1 plus 0.08 divided by 1 raised to the 1 times 10. And if you plug that into the calculator, if we simplify that a little bit, we'll have 1.08 raised to the 10th power, and that'll give you $53,973. Says because we have to round to the nearest dollar, so no cents. Okay, number 21, graph the function f of x equals 6 to the x by moving the key points. So for this, you really just need 2 points. So I'm going to use a table x, y, and 0, 1 to find the corresponding y values. You just need to plug it into the function. F of 0 is 6 to the 0, and 6 to the 0 is 1. So 0, 1. So that point stays the same. So you wouldn't move that point 0, 1. So you would just keep that first point where it's at. And then f of 1 is 6 to the first, which is 6. So 1 comma 6. So this second point, you would actually have to move it to 1, 6. And so then if you do that, your graph will look more like this. So make sure you move. I can't do it on my screen because this is just a picture of a graph, but you can physically just move that point, just dragging it up to 1, 6. Okay, number 22, consider the graph of the function f of x equals x squared minus 3x minus 4 divided by x squared minus 9x plus 8. What are the vertical asymptotes? The vertical asymptotes we find, first we need to factor. So let's factor the numerator and the denominator. So if we factor x squared minus 3x minus 4, that's what multiplies to -4 and sums to -3. That'll be -4, +1. So this factors as x minus 4, x plus 1. So the numerator we factored as x minus 4, x plus 1. The denominator will factor x squared minus 9x plus 8. And that's going to be what multiplies to 8 and sums to -9. That's going to be -8 and -1. And so you see nothing cancels out here. And so then to find vertical asymptotes, you set your denominator equal to 0. And since we have two factors, we'll set both of them equal to 0. And if we have x minus 8 equal to 0, x minus 1 equal to 0 here, we would add 8 to both sides, get x equals 8. And then we would add 1 to both sides here, x is equal to 1. So our vertical asymptotes occur at 8 and -1. I'm sorry, +1. I'm not sure where I got that negative from. 8, +8 and +1. Okay, number 23, find the horizontal asymptote of the graph 12x squared plus 3 over 3x to the second minus 2x plus 1. So in this case, for horizontal asymptotes, we compare the degree of the numerator with the degree of the denominator. And the degree just refers to the highest exponent in the top and the bottom. And if they're equal, we divide the coefficients. So we're going to divide horizontal asymptote, we divide 12 by 3, and that'll give us 4. So your horizontal asymptote is y equals 4. Okay, number 24, rewrite log base 6 of 8x plus log base 6 of 7y as a single logarithm. And so this takes us back to the product rule. The product rule says if you have log base b of a plus log base b of c, we can write that as log base b of a times c. And so in this case, we have log base 6 of 8x plus log base 6 of 7y. We can combine these as products using the product rule. We get 8x times 7y, which becomes log base 6 of 56xy. So I guess we would write 6 here and then 56xy there. Okay, number 25. What value of x makes the equation 7e to the -5x equals 17 true? So here we have an exponential equation. First, you need to isolate the base e. Okay, we're going to do that by dividing both sides by 7. And 17 over 7, we'll just keep it as that since it can't be simplified. And then we're going to apply the ln to both sides. Using what happens when you apply ln of e to both sides is ln of e is just 1. And so since ln of e is 1, the -5x, if we use the power rule, that would just come down and we have -5x. ln of e is 1, so we don't need to write the 1 there. Then we have ln of 17 over 7. And finally, we would just divide both sides by -5. And so x is equal to ln over 17 over 7 equals, divide by -5, and if you put that in the calculator, you would get -0.2, and we round to the nearest tenths. Okay, so those were all the 25 review problems from the final. Good luck on your final exam. Again, if you have any questions, please don't hesitate to reach out.